Greetings everyone. Welcome to Datagaps webinar. I am Pooja Gupta, Growth Marketing Manager at Datagaps, and I would like to thank you all for joining us today. Before getting started, we have a couple of quick housekeeping comments. First, we have muted all mics to avoid unintended distractions. And second, if you have any queries, please type it in Q&A section. We will take them all at the end of the session. Today in this webinar, we will be highlighting how GenAI-powered Datagaps DataOps suite featured mapping manager drives innovation, streamlines processes, and empowers teams to build agile data pipelines tailored to evolving business needs. On the panel today, we have David Small, VP of Sales at Datagaps, and Subhanshu Dikshit, Product Manager at Datagaps. And here is our agenda for today's webinar.
Thank you, Pooja. Well, and welcome everybody. Very much appreciate you attending the webinar. What we have planned today is really just to go through a little bit about Datagaps. We'll talk about steps towards autonomous data testing, and we'll describe a couple of different ways to do that. And we'll go into the integration of data testing with DevOps. So the DevOps that your data engineers are using can also be integrated in data testing, and it sort of drives the data testing group with the data engineering group together. And then we have a special presentation on our DataOps mapping manager, one of the new technologies that we have using GenAI. And then finally, we'll do a demonstration of that. So with that, a little bit about Datagaps. We've been in business since 2010. We're on, I think, about our third iteration of the technology and the software. And we started back in the client server era, and now we've migrated and moved into an Apache Spark-based implementation where it's a web-based interface interacting with servers that are either installed on-prem in your environment or in your cloud, but all of DataOps suite is installed behind your firewalls, and we have no access to the data whatsoever. There are 4 products in the DataOps suite. And first one's the ETL Validator. It does data quality management, data quality rules, profiling. It independently validates your ETL processes and such. We also have BI Validator that helps with regression testing and performance testing. And, we do visual comparisons to identify any anomalies between reports and so on. And then we also have data quality monitoring. So data quality monitoring gives you the ability to either monitor data at rest within your organization, could be your production applications, could be your data warehouse. It also provides observability, and we'll talk about that. And then finally, Test Data Manager, which creates synthetic test data based upon a sampling of your production data. So that's the suite of products. And first thing I want to do is really talk on the definition of 2 terms. So, there's this whole concept of GenAI that has really fascinated the world. And GenAI is embedded into our technology, and we'll show you a number of cases where we've embedded GenAI. But GenAI is really that technology that is there for producing content. So you can ask GenAI to, hey, give me a SQL statement to do this, or GenAI, hey, tell me the differences between these 2 reports. So you can tell GenAI to do a variety of things. And what we've done is we've incorporated those into areas within the product to shorten and to make the product that much easier and flexible to use. So GenAI, parts of that are already in our product, in our technology, but we're also leaning and moving towards genetic AI, and that is the ability for that AI capability to help achieve goals without constant human intervention. So think of it as being able to actually create test cases, and then the results of those test cases being able to be viewed and understood by agentic AI and decisions made, and I'll go through that in a little bit more detail. So with the next slide, what we're talking about and showing is really a framework for autonomous data testing. Now, this is our future. This is our vision. We've added the Gen AI capability in, and we're moving in this direction as well. But here is a typical Datagaps ETL Validator screen. And what you can do is, you can drag and drop things onto the screen, and that's how the test cases get formulated and such. And the reason I'm presenting this is that think about with Gen AI and Agentic AI, these tests could potentially be automatically created for you. So let's go through an example of what that might look like in your traditional data pipeline. So this is your traditional data pipeline. It's, very simplistic view of that. But you have data coming into the enterprise. It's coming in either flat files. It could be databases. You may need to use an API to call to get the data. But that data is coming into the enterprise. And what we do is we help validate that data from the point of ingestion all the way through to consumption in the data analytics platform. So in order to do that, people use ETL Validator to do that, or to do parts of that. And ETL Validator has the ability to do profiling. So it can take a look at the data that's being ingested, you profile that data, and from there, it identifies about 20, 25 different metrics like null values, the count, distinct counts, minimums, maximums, all kinds of metrics that we accumulate and figure out in that profiling. So if you drag and drop the profile component onto the palette, connect it to a data source, it does that kind of profiling for you. We also compare profiles to prior profiles, and if there are any discrepancies, we notify you of that potential anomaly. With data rules and ETL Validator, you can create data rules by interacting with our rule template. That rule template gives you the ability to test the data coming in at a granular level. While profiling gives you an idea of what the data is, what it's about, you can do very specific data quality testing with the data quality rules that can be created through a low-code, no-code type of interaction. And then we also provide ETL validation, where you independently verify that your ETL process is producing the expected results. So we actually recreate that ETL process in ETL Validator, and then you run your ETL process, you run our independent layer, and from there we generate files and we compare the files. And if the files have some discrepancies, then we provide you with the ability to go back and make those types of corrections. Now, these data quality rules that we're showing or talked about, those rules get scored, and those scores roll up to something called data quality monitoring. And so if you think about a data quality rule, that's executed at a data element level. And then that can be scored at that data element level, and it rolls up to the table. And so now the table has a score. Then it can roll up to, let's say, the data warehouse. And so now all of the tables combined give a score for the data warehouse. All those scores, if those scores begin to diminish for some reason, then what you can do is trace back down and find out where things are failing, what the rules were, what the data element is that's causing the problem for that data quality score to diminish. And that's done with data quality monitoring. Along with it, data quality monitoring brings in observability. So moving on to BI validation. So the next thing that people will use us for is, we're making sure the data quality at the point of ingestion is right, the transformations are correct, and then it moves into data analytics. So you have Power BI or Tableau, and you want to make sure that the data that you're you consumed is trusted, and that the reports that you're producing are giving you the correct results. So we do regression testing, we do pixel-to-pixel comparisons, we do data-to-data testing. We can test data from your report all the way back to the source if you choose, and that's the capability that we provide in BI Validator, and this is a complete end-to-end testing solution. We also provide the capability of doing data observability, and that's done in data quality monitoring. But as data is being ingested and moving through your organization, we provide the ability to observe that data, learn about that data through machine learning. And from there, what we do is if the data begins to get outside the bounds of what we've learned, we provide you with the ability, or it indicates that there's a potential anomaly, and it will alert you that there's an anomaly. We'll also go in today into the CI/CD integration capability. So we integrate with your DevOps environment. So if you have GitHub or ADO, you can actually invoke our test procedures and such from outside of DataOps, and you can get results back, and you can store versions. And there's a lot of good reasons why we've integrated with DevOps environments. Now, we've also already added a lot of capability into the product line in terms of Gen AI. So as an example, you can hand off the metadata, and if you choose to, you can hand off the data, and to have Gen AI create data quality rules based upon the metadata and the data. So it will come back and it will actually create data quality rules. So you don't have to create those rules any longer. It will do that for you. We also give you the ability to independently create your ETL process through mapping documents. And so you hand ETL Validator a mapping document, it hands it to Gen AI, and it produces the capability, or it produces your ETL process for you properly. And that's how you can shorten the amount of time it takes to do that ETL validation. We also provide the ability to do Gen AI against dashboards and reports. As an example, you might find that you ask Gen AI to say, hey, give me a summary of the differences between these reports, and it will come back and provide you with that capability. So we're continuing to add Gen AI in a variety of things in areas there, but we're also looking at and implementing things that would be called more agentic AI. Those processes that not only execute certain things, but also they also understand the results. They make decisions without human intervention. So as an example, what we're looking at and what we're thinking about is in the case of a data profile. So you create the data profile and you hand off the data profile results to Agentic AI. Agentic AI says, okay, based upon these results, what I need to do is I need to fire the Datagaps data quality rule engine, and I need it to generate a certain number of data quality rules based upon what I found during my profiles. So then it hands that off. It applies those data quality rules. It builds your test cases for you. Remember the palette, and it's just a matter of dragging and dropping those test cases and providing some additional information. Well, Agentic AI is perfect for being able to do those kinds of things. Along with that, maybe after you run the data quality rules, you've run the profiling, then it needs to maybe generate or call what we talk about is our mapping manager, so that and provide some intelligence and some head starts on how you should actually develop, or how it will develop, your ETL validation process. So we're trying that combination of, hey, Gen AI is great for content, great for, we've all asked it to, hey, give me a essay on ABC, or let's look at and give me some information, or create a SQL statement, or create some Python, or so on. So that's the content, but now it's that decision process through agentic AI that we're trying to add to the product, and to make the product that much more autonomous. So with that, let me stop and turn this over to Shivanshu and let him start with a little bit more detail behind what I was talking about. Thank you very much.
So what we want to start with, of course, is the discussion on what steps we have taken to reach that particular point where we want to push things more to an autonomous system, autonomous testing in a data sphere. So let's take a step back and look at what data teams do in a nutshell. What you're looking at on your screen right now is a screenshot of the Jeffel shop. It's a very popular shop, and it's an elementary data warehousing shop used to just run scripts and do testing, basically learn what data warehousing is all about. And you'll see, even if it's called quote unquote an elementary data warehouse, it still has a lot of tables, a lot of relations, correlations, associations, and whatnot. This problem statement is tenfold or even hundredfold in enterprise warehouses. And so the data teams here are asked to build the entire pipelines, maintain them. Sorry about that. And also make sure that the quality of the pipelines and data quality in itself is also maintained throughout. Now, usually this process is tagged on top of things as opposed to keeping them through within the DevOps pipeline itself. And that is something that we have always felt inappropriate about. We want to ensure that if the information of all the data sets, their transformation logic, mappings, and other aspects are present, we should be able to leverage that information itself. And we'll come to this diagram specifically in showcasing how we do that. The next thing we want to discuss, of course, is where exactly does data gaps come in this DevOps process. We have seen where we step into a particular pipeline, but for this, let's actually look at the development process and see where exactly we come in. So we're looking at a typical branch system where if there are new requirements that come in on, say, on a weekly or monthly basis, there the main branch gets forked into a proper feature branch. In the feature branch, a developer is going to define all the changes that we're going to do. Once those changes are defined, this is where data gaps comes in. You see, in a traditional system, the changes that were defined will be validated directly by the developer itself or by another QA using the same information. But this is usually done in sequence as opposed to in parallel. And this is done on top of the tasks given as opposed to in line with the tasks. So here's where the application comes in to ensure that if you're making some changes, those changes are being tracked, the test cases for those changes are being automatically created, and once these changes are actually run, there's a validation process that takes place. There's a proper PR report that's being generated. And only when these valid changes are approved by a particular approver personnel, these are pushed down to the QA branch. Here's where the autonomy of the application and, of course, the enterprise nature of the application comes into play again, because we have already defined our test cases in the feature branch. It's very easy for us to pick up these existing test cases and then merge them with the QA branch test cases to ensure that the changes that we have introduced in our new feature branch are not causing unexpected changes down the lane into subsequent branches. This goes all the way down to the release branch as well, where we do a final round of checking all the way down to the PI layer to ensure that there are no changes or unintended changes within the pipeline. This is where the application shines. We are creating test cases only once, but we are trying to use them across multiple branches. And you'll see within our system, we can use this particular set of use cases across multiple projects as well. Of course, once you define your test cases, you can always define them into their dev, QA, UAT, and prod environments, depending on your use cases. But the main thing I want to discuss here is the fact that we can version control our test cases, reuse them across branches, and of course, be part of true CI/CD. This is something we are already part of. We are part of true CI/CD, and so we are already stepping in the right point of automation there. Now that we've defined what exactly we can work from an automated perspective in terms of version control, let's see what our aim here is. This is going to be pretty similar to what Dave was discussing earlier, except we are defining this in a different block format. What we are aiming to create is, of course, an agentic agent or an AI agent here, which can fetch requirements from a particular user or contact the user itself, apply a good amount of profiling and create the rules accordingly, and of course, create the transformation validations as well. In fact, the latter two is something we will be seeing in our demo live today. And most importantly, the agent is supposed to be able to iterate on this particular test cases. If there are errors, we should be able to resolve those errors. If there are problems coming up in the particular test case, we should be able to resolve them. And if we notice that the trend of the data itself is moving into different directions, the data rules should be updated and adjusted to ensure that now if, say, the average volume that we were checking within our incoming data has increased because the size of the business has increased, we are keeping track of that. So we want to ensure that the AI agent has capabilities of capturing all this information, not just in terms of deployment of these test cases, but also capture the results of these test cases to iteratively define what the next test case will be or what the updates will be. And to do all of this test case creation and execution, we have our executioner systems. That is our entire engine that's been running for about 10 years. And we also want to make sure that the AI agent can, of course, ask or prompt the end user in case of any confusions or some specific invalid statements that it might have faced. So in this way, we want to make sure that the AI agent that we want to push with the product takes care of all the hassle of creating a QA system from the user onto its own self. Now to do this, and of course to zoom in on our specific use case today, because Mapping Manager is just the first step on top of this particular stacks that we are trying to build. We are going to look at Mapping Manager and see how exactly it helps us create these test cases. So we'll be going into a demo of this soon enough. So let me explain how this particular application works. Firstly, requirements arrive. So what I mean by requirements here are requirements in terms of, say, updating a production environment or requirements in terms of creating a brand new ETL pipeline. Regardless of what you're choosing, you will have a particular catalog system or a governance system where you're going to keep track of all the tables, their relations, transformation rules, and other aspects. This is part and parcel of any data pipeline, and regardless of the size of the warehouse, you will have some or the other documentation built in. And this documentation is either going to be in a catalog system or in a governance system. Of course, as an engineer, you're going to go in and implement the ETL logic. This is something that engineers have to do at this point. While a good chunk of code is generated, let's say, like, let me use a quote here, a good chunk of Google's code in the past year has been generated by AI. The same is not true for data systems. We have noticed across industries that just creating those rule sets directly, the data quality, the data queries itself is not exactly what the industry is moving towards as of yet. But as of now, we assume that there is a developer who is creating this ETL logic. So the ETL logic has been developed. What's happening in parallel? Well, in parallel, the QA personnel just updates the catalog and lets DataOps suite know that the catalog has been updated. The suite inherently is going to pick up all the information in the catalog. This includes the transformation rules, the mappings, lookups, and all the other aspects. And then it's going to create two types of validations. The first type of validation is validation of the transformation and migration logic, ensuring that the functions that were defined are working as intended, and also ensuring that the data is validated not just based on the transformation itself, but also based on quality rules. What I mean by this is that within your transformation logic, if your joining condition is inherently flawed, it could imply that there are duplicates within your data. So even if you have perfectly replicated the transformation logic, there will still be duplicates within your data. So what you need on top of this are data quality rules to ensure that, yes, the numbers are correct in terms of the logic, but is the logic correct in terms of black box? If you're expecting only positive numbers, there should not be any negative numbers there. If you're expecting certain date formats, the other date formats should be absent. There should be valid dates if you're working with a valid demographic system, and so on and so forth. All these type of rules are generated within the system inherently. And then the best part here, because we have achieved true CI/CD, both the ETL test case as well as the validation test cases are pushed into production directly. Again, this is assuming you want to push things into production. Of course, you can also move things from a development point of view as well. But this is an assumption where you can push things directly into your use cases. And so now let's go to this particular deck. And as I mentioned, we will be, as I said, we would return to this particular screenshot. And we have zoomed in on a particular table. It's the MDL customers table. As you can see, it's going to be used in our semantics layer, and it comes in from a staging table as well as from another simple MDL table itself. All of these come from raw tables, and this is an entire pipeline, but we'll be focusing in on one specific table. And on the left, you see that there are a lot of specific transformation logics that have to be applied here. So what likely happens is that an ETL developer sees this and creates the logic as intended and pushes the logic down and checks from a few limited stack of tables if a particular data set or transformation logic is valid, and they are good to go. However, this is where the application is going to come in, and this is the example I'll be focusing in on. All right, now let's jump into our use case itself. All right. So what you're looking at this point, let me actually open up Mapping Manager once again from scratch. All right. So what we're looking at this point is a particular use case that we had defined. So here you'll see that we had defined a particular mapping manager and we had given it a proper target table. We'll wait for a few seconds for this to load in. Yeah, there we go. Now we have moved a few steps ahead. Let's go a few steps back. All right. So here we see a particular table has been loaded. It's M customer. This is what we were working with within our catalog. A quick pointer about the Unity catalog here. So the information on the transformation logic and other aspects, the text that you saw in my slides, this information can be pulled in from multiple sources. Here our use case is with Unity because Unity has been pretty popular with a lot of Databricks and Azure systems as well. So that's what we're going for. However, if you have another governance tool set or if you have your very own type of documentation and categorization, you can use that as well within the application. We're always building the product to ingest files directly in terms of connecting to catalogs or governance tools. The next thing you'll see is that the application automatically picks up what are the tables that this particular target table has been built out of. So going back to our slide, if I can move there momentarily, stage customers and stage orders is what combines to becomes MDL customers. And you'll see these are the two tables that we've picked up. And our target is singular, so these are the target systems that we are working with. Now, one of the most important aspects comes in terms of the transformation rule itself. So you'll see that similar to our table, most of them, as you can see, just a couple of columns have no transformation. These are picked up directly from a staging table. However, others are a little different. So here we have an expression where the transformation logic is that we need to identify the number of unique order IDs placed by each customer. So you'll see that the application inherently picks up that this is orders, and we are most likely talking about something called order ID. See, this statement can be generated using GenAI as well, or it can be put in by a human manually if they have to, or can be pulled in by the governance or Unity catalog. This is what our GenAI system is going to use to create this particular set of transformation logic. In fact, you will see such kind of use cases everywhere with regards to ensuring that the earliest date of a customer is being placed, the last date, and of course, doing any kind of financial calculation as well, in terms of total tax calculation, total lifetime spending, and of course, if a customer type is returning or repeat. This is a pretty cool one because here there's no column as such. We just need to understand how a customer can be returning and how a customer can be a repeat buyer. So again, this is pretty, how do I put this? It's a pretty, say, contextual use case where returning and new could mean anything, but given that we define the context here and we provide the generative AI these contexts, it's easy for it to create the rules. So what exactly is it doing in the first part of transformation validation? Well, let's do this live. We like to do live Gen AI use case demos itself, and we keep some backups in case these don't work out. But in most cases, they work out pretty fine because what the application is doing at this point is that it's keeping hand of the transformation logics there, and it's sending it to a generative AI system. Now, here's the kicker, the best part. While you can easily connect to OpenAI, Azure OpenAI, Gemini, and all other types of use cases or LLMs which are outside your system, the application comes with the boxed-in product itself. What I mean by that is that there's a fork of Llama that we use that we ship with the product. So you at any point will never have to send any information outside your system itself because, as Dave said at the very start, the product can be installed within your infrastructure itself, and this particular LLM, this box LLM, comes with the product itself. So let's see something that happens, and this can happen quite often, and this is where the agentic AI is going to come into play, which is that when the application creates these queries, it does the first pass of the query and also gives you the error that, okay, I've tried to create a query and I've tried to run it, but this is an error that comes up. This is, to be very honest, very human-like because you're going to create your queries yourself. And of course, you're going to face some of the other errors that you might see right there. And an easy way to kind of fix this is, of course, by regenerating the use cases itself. In fact, before I regenerated the use case, I could have actually just copy pasted this entire error message into the prompt and asked it to use that information to create the best use case. And that is what our agent is going to do in terms of iterative systems. Because you cannot expect a generative AI system to create the perfect code on the very first go. But if you can teach it to see, as you can see, it's getting better. As you can teach it to the, okay, these are the transformations which are working better. And for these, we see that there is an nvarchar issue. So we can just add it here and ask it to regenerate. And again, so because it's a box LLM, there's no severe infra cost for this either. This is just a pretty lightweight system for us to work with. And what this basically ends up in, while this is running in the background, I'll just show you one use case where all of this runs inherently. And you'll see that the application, and this was the first try, the other one, since it's a live demo, it tends to fail sometimes. But as you'll see, if you want to ensure, like in this case, you want to classify customers as returning or new, the application understands that returning would be the count or distinct count of order IDs greater than 1. And in this case, if you want to ensure that the last order is the most recent one, max is being deployed. So if I go back to my use case, you'll see most of the use cases have also been defined in this particular system as well. In fact, it has also defined the cast function, which was causing the issue earlier seen, which was it was a character instead of decimal. And so the application understands that and then tries to fix it. This is the first type of validation, which is validation of the transformation logic. And if I go ahead and create data flows, it's going to create a lot of data flows for my system. And what it's also going to do is that it's going to kind of aggregate multiple transformation checks into multiple data sets. So if there are columns where there is not a lot of change, you will see in this particular case that the source is picked up as is and the target is picked up as is. There's no real transformation present here, and the data comparison is telling us that, well, the source and target could be mismatched itself. So there's an issue here in terms of source to target comparison. So what we're trying to do here is that, well, the source and target themselves were incorrect. So what means here is the simple migration itself has failed. That's one type of failure that we have captured. Now let's go back. Let's see another type of failure that the application captures. Here we have a shift. We see that instead of just a select star query, there's a transformation applied. We're checking for the minimum order as well as the maximum order for customer IDs. In the source, we apply our transformation function. And as you can see, this was generated using AI itself. And in the target, we see that, well, we are picking up the columns as is from our target. So there's no transformation required here, but there's a transformation logic automatically created in the system. And here we see that once again, there are mismatches. The actual transformation logic has been incorrectly deployed within our system. In fact, there are very few matched records that are actually following this logic of the latest date versus the oldest date. Now, this could very well be because of an additional filter condition that the developer had added based on the corresponding documentation he or she has seen. But if you're looking strictly at the transformation rule, we see that this particular test case has failed. And so using this particular system, what we've basically done is that we have defined validations on each and every type of transformation rule that we have defined. And all of this was done automatically, albeit with a few additional regenerations, but we reached there easily. So that's our first step. We have created the test cases. We have made sure that the test cases are merged in together as well, so as to not create a test case for every column. We try to merge things together where it's possible to maintain sanity as well. Or else you'll have a lot of test cases, and if you merge everything together, then you'll have a mess understanding exactly where the problem statements lie. So we kind of go for the middle ground here, where different types of test cases get grouped in together. That's the first thing. The second thing is that now that our test cases have been created, since we have Git enabled within the system, all test cases can be easily version controlled, and you can track your changes. Currently, what we are trying to do is, let's say within the tax paid, it's a simple aggregation. But what if we wanted to shift it? Instead of calculation of total tax paid by the customer, we wanted to see that the total tax is, say, a discounted tax that we want to add. So we want to add discount here before the tax has been paid. That change can be tracked both in terms of the test cases themselves as well as the code changes. And that's one of the key aspects of version controlling. And the main reason I've showcased the slide before on CI/CD, because we can keep track of the changes as well as keep track of the test cases themselves. And of course, it's not just that. This kind of includes a complete test coverage and the fact that we can search throughout this repository itself what is a different type of changes, what are the test cases, and if this particular type of test case has been used before, we can easily reuse it as well, and so on and so forth. There are a lot of different use cases as well. But one of the key things that distinguishes us from our competitors is the fact that we can smartly create these test cases as well as group them together and of course run them in an executive pipeline as well. So that even if you're working with a variety of sources, be it CSV files, Excels, JDBC connections, API connections, BI connections, you can connect to all of these and define these test cases accordingly. So that was the first part of the use case. There's still the second part. And this is pretty cool as well. And as you can see, the application has generated the data quality rules for the same. And this has a lot of variety in it. It's not just kind of validating the rule sets against the source and target here as well, making sure that the expected spend time and the final spend time match, but it's going on a bit more on top of it. It's ensuring consistency across data sets. It's ensuring that a particular tags that we're working with is not a negative number. It's ensuring that the classifications that we're working with are the classifications that we had defined in our ETL logic. So we had defined that the classifications are only returning and new. So if there is anything other than returning and new, well, it's incorrect. So if a developer comes in and applies a new logic, so that, okay, there are 3 types of test cases now, it should be reflected within the test case generation as well. And so the application is going to capture these changes inherently. And in the future, the agent AI or agentic AI is also going to keep track of these changes. That previously we had just 2 categories. Now we have 3 categories. So this particular rule will also change. And all of these rules that you see are created using generative AI as well. In fact, I have another set of rule sets right here along similar lines, where a similar type of rule sets were created, which ensure the classifications are in check, which ensure the customer IDs are in check, consistencies are in check, and so on and so forth. All of these rules can be easily added to our data model to create the corresponding data quality score that we were seeing. So since you see there's a lot of issues within our system, we can easily add this particular set of data quality rules within our use cases right there. And as you see, all the rules are added right here. And this is going to generate a proper data quality score. And so what we have basically achieved using the mapping manager is that we have reduced a lot of overhead from the end user. The end user now only has to define the connections once. They have to pick up what the ETL developer already works with, the documentation, be it in terms of a governance tool or in terms of a catalog or in terms of, say, Excel files. Yes, we can ingest Excel files as well for this particular process. And once these are ingested, the application takes the wheel. It does most of the transformation validation, most of the quality validation. And as an end user, at this point, we only expect you to do a bit of monitoring, ensure that what you're looking at is what you're expecting, and you're good to go. But our next steps moving forward is to remove that process as well. We would want you to be the final use looker in this particular system. Once this entire system is deployed, you can zoom in and see exactly what an issue is. The application should call out the places where it finds that there could be issues or doubts where the confidence of the agent itself is low, and you can come in at that particular point and fix the code if required, and so on and so forth. But this in a nutshell is what Mapping Manager is. A combination of transformational validations and quality rules within a single nutshell. And as you can see, during this entire particular demo session, I have not written a single line of code. And so that's what we are trying to aim for here as well. So yeah, that is Mapping Manager. I'd like to thank everyone for their time for this demo. And I'd like to bring in Pooja if there are any other questions or other aspects. And of course, Dave to close us out after that.
Sure. Thanks, David, for sharing insights on how Datagaps DataOps Suite could help building agile data pipelines tailored to evolving business needs. And Shubhanshu, definitely for an extensive demo of Datagaps GenAI feature for the same. So we do have queries in our Q&A section. First is, how does GenAI enhance the process of building and maintaining data pipeline?
That's a very good question. So when you're talking about building data enhances the process of building data quality pipelines or data pipelines in general, it's the fact that you have a lot more automation on your side now. An easy way to define this is, now that you have, say, 6 tables which are going to be combined into a single table. So here we were lucky, we have just two tables joining into one. But in a lot of cases, you're going to have upwards of 6 and 10 tables. It's very good to have an assistant to help you keep track of your code. There's a lot of code assistants at this point which help you keep track of any, say, stray joins or any kind of conditions. And in fact, what we are trying to build, and since we are trying to build a good amount of our very own box LLMs, we see that if you provide these LLMs with a bit of record information, a few sample records, their code quality increases tenfold. That's the main reason that we have a box LLM, is that we want the end users to be able to give some sample records as well. So from the creation perspective, as well as from the updation perspective, keeping track of what the data trends are, updating the values accordingly, as well as execution of these in terms of scaling their clusters, their volumes, and other aspects, generative AI comes in on every place. And what we are trying to do, and I think the industry is moving towards, is to make sure that, the generative AI takes care of all this entire hassle of heavy work of repeating the same rules across multiple data sets, and give humans the more important task of keeping track of the direction in which this particular pipeline quality or say ETL transformation logic should go. So I would say that that's where we are headed there.
Sure. Thanks. Thanks, Shubhanshu. Next is, can AI-driven automation handle complex error scenarios, or does it require human intervention?
Oh, that's a very good question. And that question comes from someone who has tried to kind of do this thing as well. So, well, obviously, since it's generative AI, there is a grain of salt. We are looking with something more specific. However, in my experience, if you have tried to go ahead with more complex use cases, let's define some complex use cases. So I have this particular example, which I demo quite often in my demos that of Datagaps, is we have windowing functions and with partitions and a couple of joins. So it's a table, it has a few partition joins, and it has a few window functions, and it has a few, say, joining keys as well, all mapped in together in a 26 column table. So, well, in our experience, that would be perceived as at least above average in complexity. And the application about 90% of the time gets those window functions correct as well, given that we provide the context correct. So I would say, yes, the application can do complex functions as well to a fair degree, but I would say context there is very important. Context of additional reinforcement of the fact that we need to work with the correct schema, the correct data warehousing, the correct Spark SQL version, or in this case, JDBC SQL version, anything that you're working with. The more context you provide to the system, the better the queries are, and it has been able to handle complex queries as well. However, in this case, other queries are at 99%, the complex queries are at 90 or 85%. So there is a grain of salt at this point, and we'll be trying to update our box LLM to make sure we are competing with OpenAI and other aspects as well, if possible.
Sure. Thanks a lot, Shubhanshu. And the last question is, how does the tool ensure error-free data flows, specifically in large-scale deployments?
So the error-free aspect comes both in terms of generation as well as in terms of execution. So as you saw, when I was generating a particular test case, the application does a first pass for me to ensure that if the test case has an error, inbuilt error, it's called out right there. It's not going to let me create a test case unless I fix that error first. So if I go back right here, if I regenerate these test cases and if there are some issues there, there's going to be a red marker saying that, hey, this has an issue. Maybe there's an ambiguous column. Maybe there is a cast which has not been deployed or other aspects. So the generation itself is going to be error-free because the application calls out them using first passes. And of course, in the future, we'll try to do it iteratively as well. And in the execution as well, there are always special cases of to halt pipelines, pause pipelines, or even do conditional clauses on pipelines in case of errors. The application is going to run in accordance to what you have defined. So if there is failures of test cases, so if you are looking for duplicates and you have found a duplicate, the application is going to validate the other test cases as well, unless you have specified otherwise. But if you want to, say, pause a pipeline, stop the pipeline, or say skip particular test cases or steps, you can do that as well. We make sure that the application inherently has this customizability built in.
Great. Thanks, Shubhanshu. So this is the end for today's Q&A section. We don't have any more queries. And thank you everyone for joining the webinar. If you have any queries specific related to your use case, you can contact us at contact@datagaps.com. Over to you, Dave. Thanks.
Thanks, Shubhanshu and Pooja. Yeah, we greatly appreciate your interest, and this is been in business, as I said, since about 14 years. We've continued to enhance and innovate in the technology, and I think this is just one of the next steps is the Gen AI implementation, which we're well down that path. But Agentic AI as well, and to help make the decisions and not necessarily take the things out of the hands of QA and data engineers, but enhance their ability to do more and provide some oversight on things as well. So we thank you, and we look forward to hearing from you. Again, if you have some questions, feel free to reach out to us, And you can visit us at www.datagaps.com. Thank you all.